Hello Legacy students, Marsh here. So today we're going to look at scientific notation. More importantly, what is it and how do we use it or do it? So why is scientific notation? Well, long ago, mathematicians and scientists realized that they have some numbers that is way too big or way too small to keep track of and use and operate with. So they figured out a way to rewrite them so that they were simpler to remember and to work with. So why does it work? So you've probably seen a number in scientific notation before, 4.5 times 10 to the 5th. You've probably seen this in science. Well, what that means is you're going to take 4.5, the number, and multiply it by 100,000. Well, 100,000 is 10 to the 5th power. Just think about it that way. 10 to the 5th, do it on your calculator quick, that is 100,000. However, by multiplying by 10 is the same as moving a decimal point to the right. So what means we can change these numbers quicker. We do not have to do 10 to the 5th and then multiply by 4.5. All you need to do is just move decimal points with these particular problems. So let's look at how to put a large standard number, so like 450,000, into a scientific notation. So the very first thing we're going to do is we're going to move the decimal, which is normally in the back of the number, so that the first number will be less than 10 but greater than or equal to 1. So basically you're more than likely going to move the decimal point until you get to the first number you want the first number in the front, or only one number in front. We're going to count how many places you had to move, and then that's going to become the exponent of the 10. We're going to get rid of any zeros that were present before we start moving them, okay? So let's try the other things here. We know the weight of the Earth is that really large number, in kilograms. We're going to write this number in scientific notation because this is really hard to read, right? Too many zeros. So my decimal point right now is all the way back here. So what I'm going to do is I'm going to figure out how many moves of my decimal point would it take me to get me right here. So I'm going to put little like bumps as I go along. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. So it would take me 25 jumps to get from the back of the number to the front of the number. Notice this number 6 is less than 10 but greater than 1. So that's why he can just be in front. So I'm going to have 6.0 times 10 to the, and it took us 25 times, so it'd be 10 to the 25th power. Because think of that. That would be this number with 25 zeros attached. This times that would get me that. That's ultimately what we're doing. Now we have the weight of the largest animal on Earth, the blue whale, is 180,000 kilograms. Let's write this number in scientific notation. So I got 180,000. Now, this is not too bad, but sometimes it's nicer to work with scientific notation numbers. So right now I have a decimal point in the back here. So let's figure out how many times do I need to move to get between these two numbers, 1 and 8. So 1, 2, 3, 4, 5, right? 5 times. So it'd be 1.8, the number here, times 10 to the 5th, because it took me 5 jumps to get between the 1 and the 8. Now, what about putting really small numbers into scientific notation? Excuse me. So we're going to have to move the decimals so that the first number is 1 or more, but less than 10. So kind of like the same thing. We're going to count how many places it takes me to move the decimal point. Now, since we're making a small number big, right, because we're going to have like 0.000005, and we're going to make it 5, we're going to have negative numbers for my exponent of my 10, because the negative tells me instead of moving to the right, we're actually going to move to the left. Alright? So I have the weight of a molecule, really tiny number. can't imagine how many zeros that is. It's going to take me forever if I would ever actually want to work with it. So let's place it in scientific notation. So ultimately, guys, I'm going to want my decimal point to appear right back here. Do you see that? I'm going to want it to appear there. So let's take it and figure out how many times it's going to move me. So I got to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. So I know I'm going to have 3.0 times 10. Now I moved to the right, right? I made a small number big. So I'm going to have to the negative 26. That's 26. There we go. To the negative 26. So it took me 26 moves to get to the back here. Now notice this negative. It's because I want this big number to look smaller. Okay? So ultimately, when we start expanding them, making it from scientific to standard, that is why that would be doing it. Oh, changing, not large numbers, small numbers. Whoops. Weight of a grain of sand is that in kilograms. Let's write this number in scientific notation. So ultimately, I'm going to need to move this to 3.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I know I'm going to have 10 to the negative 10 power. And I'm going to have 3.5 for the number in the front, or what's called the coefficient. Alright, how do you put a number back into standard form? So what if I have in scientific notation, what are you going to do? So first of all, you're going to write the number in the front of the scientific notation. That's the coefficient, or the 3.5, or the 3.0. Then you're going to move the decimal point to the right or the left based on the exponent on the 10. If it's a positive exponent, you're going to move the decimal point to the right because you want a small number to become big. If it's negative, that exponent, you're going to move to the left because you want that big number to go small. Then you're going to place zeros in the spots that you've already created and then add some commas if you need to. Let's try a couple of examples. In the positive, let's make them bigger. Because notice I'm going 10 to the 4th, right? So I'm going to put 3.5 times 10 to the 4th. So, very first thing, I'm going to write my number here. And this tells me I got to move 4 to the right because I need to make this number bigger. So 1, 2, 3, 4. Decimal point's going to end back here. So now for every jump I made, I need to put a 0 in the spot. So now I have for my answer 35,000, right? What about 1.02 times 10 to the 6th? Well, I'm going to write 1.02. This tells me I got to move 6 to the right. So I'm going to go 1, 2, 3, 4, 5, 6. Decimal points back there now. Add some zeros in. If I can rewrite my number here and put some commas in. So I got 1,020,000. That would be the standard form of 1.02 times 10 to the 6th. Now you can kind of see why it would be a lot easier to work with the standard form here rather than that, because you have to count the zeros and make sure you type them in correctly. Now let's look at getting a big number down to a small number. So notice it's 10 to the negative 3. So I got to make sure I got to move my decimal here. Now, I'm not going to move to the right because it's negative. This is saying you got to move, I got to make smaller. So, I'm going to move, instead of to the right, I'm going to move to the left. So, 1, 2, 3. That means my decimal point's right here now. Fill in my zeros. So, I got 0.00342 for a final answer. Let's try it with this one. I got 2.95. It says I got to move left 4. So 1, 2, 3, 4. So I have now an answer of 3 zeros, 295. So 0.000295 for my final answer. And that's the end of this video. See you later, Sabers.